All right, College Trig, here's our notes, 9.2, day 2. Big thing that you guys got to notice here is we're now changing it from being centered at the vertex to having a horizontal and vertical shift with our center is always going to be at HK, very similar to how we did it in college algebra. So one thing hopefully you guys got from the previous lectures, you always got to be able to first decide which equation you're going to be using. Either are you going to be dealing with x squared or are you going to be dealing with y squareds, right? X squareds are going to be of the format of concave up or concave down. Our previous equation was x squared equals 4ay. If it's concave left or concave right, we knew it was y squared equals 4ax. So that same knowledge base needs to be carried over to today, dealing with, well, am I going to be dealing with a x squared term with a concave up or concave down, or am I going to be dealing with a y squared term, concave up or concave down? So that is going to be really important to do, and a lot of that should be determined from what you're given information, whether it's your focus and vertex or vertex and directrix. You should be able to decide if it's going to be concave up, down, or left and right. Okay, so our example that we're going to work through today is go ahead and be able to graph this by labeling our vertex, focus, and directrix, and our lattice rectum points here. So if we're given this equation, our goal is to go ahead and put it into one of two equations. Well, I notice this is an x squared term, so I must be dealing of this format. So I need to somehow get it over here. So notice there's a perfect square in both of these formats. So we're going to be completing the square a lot in this unit. So here we're going to start with our x terms and move everything over to the right side. So I'm going to have x squared plus 4x is equal to 8y plus 20. Okay, well, I'm going to complete the square. So take b divided by 2 and square it. Well, that is going to be 4. So I'm going to add 4 to both sides. So by adding 4 to both sides, I get this. Now, here's my perfect square. I get x plus 2 squared equals 8y plus 24. Notice at this point, my goal now is to be able to get y by itself. So to get y by itself, you just factor out the coefficient in front of y. So I'm going to factor out 8 in front of this, and then I get y plus 8 times what is 24 is 3. So now I have my equation in my standard form. So now I can identify my h and k value, my center. So my h is going to be -2. My k is going to be -3. I know my a value, so remember that my a value is 4 times this. So now I got to factor out a 4 from this 8. So I can write this as x plus 2 squared equals 4 times 2 times y plus 3. So this is my a value. So my a is equal to 2, so I can find my directrix and find my focus. Okay, so let's go ahead and move this to a graph. Here's how the book worked it out, and you see your a and your h and k. So when you graph this, go ahead and graph our center point here being -2, -3. So there's my vertex. Okay, so -2, -3. I know that my focus is going to be, because my x squared term over here, right, is positive, I know it's going to be concave up. So that puts my focus above my vertex, and my directrix goes below. So then if it's a horizontal line, I know that this is a y equals something. Well, If I'm at 3 here and I go 2 more down, I'm going to be at 5, so negative 5. My focus is going to be 2 up and 2 over, so I'm negative 2, negative 1. Okay, and then I find my lattice rectum. So remember, my lattice rectum will always have the same value at my focus. Well, this value here is y equals 1. So I go ahead and plug in 1 into my formula. And so what do I get? Or y equals negative 1. So I plug in that value into my equation. Okay, so negative 1 plus 3 is 2. I get 16. I solve this out. Notice, unlike my lattice rectum points before, when it was centered at the origin, everything's symmetric, so you always got plus and minus an answer. Well, now when you solve it, you get plus or minus on this side, and it's not always going to be symmetrical because you take the square root here, and you get plus or minus 4, and you subtract the 2 from both sides, and you get, if this was negative 4, you get negative 6. If it was 2, minus 2, or it was 4 minus 2, you get the 2. So we go ahead and get these values here for our lattice rectum at negative 6 and 2. And those points will be directly out here. And from that, we can go ahead and connect our dots and have a general shape for our parabolas. On exams and other type of sets, these are the main points I'm going to be looking for. 1, your vertex, your focus, your directrix line, and your 2 points off from your lattice rectum. That concludes the notes for tonight. Make sure you come ready for questions. Thanks a lot.